Hey guys, welcome back. We're in our last video of triple integrals of cylindrical and spherical coordinates. This last example is asking us to take this triple integral in Cartesian and convert it into both cylindrical coordinates and spherical coordinates. So we're going to start with cylindrical coordinates first, and with both of these, the first thing we're going to do is we're going to use the technique that we've discussed in other videos. The fact that our dz is actually the interior is actually going to correspond with the interior integral that you see here. So what they're giving us is they're giving us that z is going to be equal to the square root of 1 minus x squared minus y squared, right? So that's the equation that's given to us. So since we're looking at cylindrical coordinates, the first thing we're going to immediately acknowledge here is that we can easily simplify this to cylindrical coordinates because x squared plus y squared is equal to r squared. So all we need to do is rewrite this equation and replace x squared plus y squared, if I pull out the negative, with r squared. And so that's going to be the upper bound for cylindrical coordinates. And very easily, they already give us that the lower bound for our z value here is going to be 0. So easy, we're good, wonderful with that. So then what we're going to do now is use our trace to find out our bounds for our radii and for our theta. So we're going to also remember that now we're looking at dy, and so these are the equations of y. So y is going to be equal to the square root of 1 minus x squared. We have done this several times in previous videos now. When we have square both sides and move the x squared over, we get the circle of x squared plus y squared is equal to 1. We do want to be a little careful, as we have discussed in previous videos, guys, is the fact that when we do this, we're looking at the positive square root of 1 minus x squared. So we're going to be looking, if this is the x-axis and the y-axis, we're going to look at the semicircle that's bounded by the top by the positive square root of 1 minus x. And then also, we're going to acknowledge that our bottom is going to be this y equals 0 that we see right here. So we're also going to bound it in exactly we see as our semicircle. And so then the last thing we're going to do here is we're going to look at the fact that x is equal to 0 and x is equal to 1, right? So x is equal to 0, well, that's going to be the y-axis, and x is equal to 1 is going to give us the equation that we see right here. So what we essentially have is this region right here. So this is what we're going to use to find the radius and the theta, which is pretty easy for us to do. Well, another thing we could have done is realize that x squared plus y squared is equal to 1. Therefore, we know from the previous, just actually talking about z here, is that x squared plus y squared is equal to r squared. So we get that even visually, but also with our equation here, that our outer bound is going to be 1, right? So no matter where we look on this curve, our radius is going to be 1 on the outer bound. And so the radius will have an upper bound of 1, and we'll have a lower bound of 0, right there. And then the cool thing about theta, guys, is the fact that theta is actually in both cylindrical and spherical coordinates. So when we find it here, we actually find it for both. So we're going to look at the fact that theta starts at 0, and it goes all the way up. The curve goes all the way up to our positive y-axis, which is pi over 2. So we are now able to write this out because we have our bounds for our cylindrical coordinates. So let's go ahead and do that. So for cylindrical coordinates, right here, we're going to go and look at our theta, which again is between 0 and pi over 2. So go ahead and put that there. Then we're going to look at our radii, which is going to be 0 to 1. And then we're going to find our z function, which is going to be 0 and the square root of 1 minus r squared. Sorry, my computer is still doing some dragging. And then we're looking at the fact that we have the square root of x squared plus y squared plus z squared. So for the third time, I believe, we're going to replace x squared plus y squared with r squared. And so we have r squared, and then we're going to leave z squared here. And then we're going to have our infamous r, and then we're going to do dz. sorry. Again, my computer is dragging right now. So we have dz, dr, it's getting worse, and then the theta. So that is this in terms of cylindrical. So what I'm going to do is I'm going to do a pause here on this video, and I'm going to end this one here because my computer is dragging quite a bit. And so I'm going to do another video right after this one where we still talk about spherical. So this is where we'll end this one, and I will see you guys very shortly in our last video for this lesson.